Good morning, everyone. My name is Sérgio Rebelo and I am a PhD student at the Centre for Informatic and Systems of the University of Coimbra. I am here today to present the installation Portraits of No One. This is an interesting installation that I've been developing along with Tiago Martins, João Correia, João Bicker and Penousal Machado. As the name suggests, this installation explores the portrait as an artistic subject and, in fact, portraiture has been an important subject in history of art. Over the time, the artists have been exploring this subject with the objective of immortalizing the image of people and consequently their physical and intellectual positions. However, with the invention of photography, everything changed. This new technology first became the major medium for portraiture, and portraits, which were previously an expensive luxury, became affordable for almost everyone. This way, photography gradually becomes a suitable way to prove the identity of someone. Nowadays, photos are an important identification tool and are present in everyone's wallet. The recent advance in computer vision and artificial intelligence developed techniques that quickly generate images, especially photos, with the realism without parallel. These techniques enable the generation of fake content that may be used for propaganda and defamatory purposes. This is a very important issue since, by tradition, photos are considered proofs of evidence. So, with this context in mind, you develop the installation Portraits of No One that explores these subjects in a form of an interactive media art installation. Briefly, this installation generates and presents photorealistic portraits of artificial people. In other words, it generates portraits of no one. The installation creates portraits by recombining the facial features of its visitors, and the generated portraits display a high level of photorealism. So, these portraits live in the borderline between the real and artificial, enabling the viewers to question themselves about the veracity of the faces that are seen. This installation was a finalist artwork of the Sonai Media Art Award during its 2019 edition, and it was exhibited at the Portuguese National Museum of Contemporary Art, Museu de Chiado, in Lisbon, Portugal. In this exhibition, the installation was designed in a room specially made for the purpose, with a 6-meter long and 4 meters wide. The space of the installation comprised two main areas: the input area and the output area. The input area is located next to the entry of the installation. In this area, you can find a capturing box attached to a pillar. This capturing box allows the user to capture their faces. These faces will be used to feed the installation and consequently to generate portraits of no one. On the other hand, the output area is located in the back of the room. This area displays an immersive audiovisual experience that is the core of the installation. So, in this area, you can find the necessary hardware to create this experience. These hardwares include 3 projectors and a loudspeaker. Both are attached to the ceiling of the room. The typical user interaction is very simple. First, the user enters in the space of the installation. Next, he or she approaches the capturing box and observes her or his face on the screen in the mirror-like fashion. If the system recognizes a face, the push button on capturing box becomes white and blinks fast. Otherwise, the button remains red and blinks slowly. So, when the button is white and the image pleases the user, he or she presses the button to capture the face. After, a countdown of 3 seconds begins and then the face is captured. Next, the capturing box pauses for a couple of seconds to avoid too frequent captures. And finally, the user goes to the output area and sees new portraits generated using her or his facial parts. The hardware of the installation, like the space, can be divided into input and output. The input hardware is responsible for collecting the data needed for the installation to operate. This data includes images of the user faces and the sounds that they produced during their interaction. On the other hand, the output software is responsible for displaying the audiovisual outputs and providing feedback to the users. The computer is the core part of this installation. It is responsible for collecting all hardware parts and managing the inputs and outputs. Besides that, the microcontroller also allows the computer to communicate with a push button and triggers the capture of data. The input data is collected through the capturing box. This capturing box is composed by a video camera, a square LED ring, an LCD display, a microphone, and a RGB push button. As before mentioned, the capturing box is attached to a pillar. Its center point is at the height of 160 centimeters, and the wall in front of it is covered with black flannel, enabling a uniform background in the captures. The capturing box was entirely designed and developed in-house by us. This allowed us to control all aspects related to the design and development of these hardware parts. On the other hand, the output hardware allows the generation of the audiovisual environment. This environment is created through the projection of the portraits and the play of the ambient sound. This way, the installation employs 3 video projectors and a loudspeaker, both strategically positioned on the ceiling. The result is a surrounding video projection of 12 meters wide that presents a large array of the portraits with a proper quality and size. The software parts of the installation collects data using the input hardware, processes this data, generates new data, and displays them using the output hardware. This software was mostly developed in Java, using the open source libraries Processing, OpenCV, and dlib. We also use Max for sound recording, processing, and reproduction, and Arduino for programming the microcontroller. The software may also be divided into input and output. The input software is the part of the system that manages the capturing box. One of its key features is the real-time face detector. These detectors analyze each frame on the camera feed and detects the face of the users and their facial landmarks. In the context of this work, we are interested in neurofrontal pose to ensure the visual coherence between the different portraits. To achieve this, we implemented a set of detection filters that determine if a detected face should be considered as valid. When a valid face is detected, a rectangle is drawn around the face. This rectangle marks the area that will be copied and used to generate a new portrait. The aspect ratio of this rectangle is always the same, 3 by 4, and its size and position are defined by the facial landmarks of the face. In addition to the rectangle, the system now changes the color of the push button from red, which indicates that no face is detected, to white. Also, a message inviting the user to take a picture is present on screen. When the user presses the push button, the system starts a countdown of 3 seconds and then captures the face. In the end of an interaction, the system saves the following data: the image of the face, a sound sample of the interaction recorded from a few seconds before the face began captured to a few seconds later, the points of the facial landmarks calculated during the detection, and a timestamp indicating the time when the face was captured. After capturing the data, the output software can generate new portraits. The output software integrates 3 modules: the generator of portraits, the selector of faces, and the producer of ambient sound. Generator model employs a generative process based in X-faces system developed by Correia et al. The input of the generator model are 5 faces and their facial landmarks. One face is the target face. The target face is the face whose facial parts will be replaced by parts of other faces. The other 4 faces are the source faces. The source faces are faces that will provide parts to be blended onto the target face. In this case, the parts are the eyebrows, the eyes, the nose, and the mouth. The process is the following. For each face, it calculates the face de Lanois triangulation, using points from face landmarks. The triangulation of these points allows us to divide each face image into triangles, which tends to cover the corresponding facial features between the faces. Next, it warps its source face triangle to the corresponding target face triangle using angular transformations. This creates source faces that are fully aligned with the target face. After, it checks if the open part of the source face is compatible with the target. It does this by calculating the intersection of a union of the bounding box with a certain threshold. If the resulting value is above the threshold, we consider that the part is compatible. If the part is compatible, it uses a seamless cloning algorithm to blend the region of source faces into the target image and delimit this part with a mask calculated using the specific vertex resulting from the de Lanois triangle. If at least one compatible swap occurs between the target face and the source faces, it generates a new face. We are some portraits developed in the context of this installation and displayed in the museum. In other words, we are seeing portraits of no one. The selector model chooses the face that will be displayed on the walls of the installation. This model selects at random real faces and provides them to the generator model that will create new portraits with them. This selection process takes into account the timestamps of the faces, tending to select more recent faces. Each portrait is displayed with a lifespan of 10 to 20 seconds. When a face lifespan is over, the selector chooses a new face, asks by a new portrait, and replaces the old portrait by a new one. This process is repeated whenever the lifespan of the portrait is over. Once in a while, the selector chooses a real face at random and displays it, contaminating the installation with real faces. Finally, the producer of ambient sound combines sound recorded by the capturing box and reproduces the results using a loudspeaker. The sound is generated from mixing 12 samples selected at random. Since most of the interactions occur in silence, we'll decide also to play a bass sound sample in the background at a lower volume. Generally, the result is an imperceptible sound that results from the mixing of the captured noise. However, sometimes we can recognize some words or even sentences. This provides a sonic environment wherein the user has the perception that the portraits are talking between them, as you can hear right now. Finally, the installation was an exhibition for almost 3 months. During this time, we observed multiple relationships and interactions between the viewers and between the viewers and the artificial portrait. An interesting relationship that we observed is that most of the viewers look at the generated portraits as portraits of other real people. So, they start to judge their visual appearance. However, when they recognize themselves or familiar face, they completely change their behavior. At these moments, the viewer developed empathy by the artificial person they were seeing and with the others who, like them, are blended together to generate a portrait. I will finish my presentation with a video that we designed to document and present the installation. I am finishing my presentation here, so you may get in touch with us by email or following our website and our Instagram account. Thank you for your time and attention.